see, so covering chapters, what is on this? Oh, projectile motion, and then also chapter 4, all of chapter 4. So the big things there are, well, projectile motion, that's kind of a big thing. The 2D forces, the inclined planes, which you'll have several of those in various ways. You also have several projectile motion problems. They're, just sort of bits and pieces of things, like I might ask you, what's the x component of the velocity, or what's the y height, or what's the time that it's in the air, that sort of thing. But we can look at some different things like that if you want. At projectile motion, that's sort of the big thing, and then the 2D forces are also a big thing. But you'll also see 1D forces, and then some problems just about conceptual stuff about Newton's laws and motion. Make sure you know those graphs where it shows the velocity versus time or position versus time as it relates to projectile motion. Set a thought. I'm sorry. Oh, it'll come back to me. But what would y'all like to start with on this? Projectile motion? All right. Oh, I remember what it was. But I did pull some questions from the OpenStax quizzes. So from your assignments, just like I did on the last test. I don't know how many, pull 3 or 4 maybe. But just go back and look at those. Make sure that you're familiar with them. I changed the numbers if it's a calculation, but they're still the same. I pulled them verbatim. You'll even recognize, like a figure here or whatever, you'll recognize it. So make sure that you look over those. Look over the concept tests, look at the old exams, look at your homework. You know what you're seeing by now. But all those things will help you on the exam. All right? Let's look at some old test questions. We'll go back to fall 2013 and look at some projectile motion problems. So, like for example, this one, this is a lot like what we did in lab, actually. I have an airplane. It's traveling at a ½ kilometer above the Earth. That's at 500 meters. Yeah, 500 meters above the Earth. And at a speed of 42 meters per second. At what distance d should it release a heavy bomb to hit the target x? So really, we want to know what is the distance d. Now, in projectile motion, the first thing you want to start looking around for is the what? The time, right? You want to start looking around for the time. So I want to figure out how long is it going to take a projectile to get from the plane down to that point x. And excuse me for just a second. Let me download this because it won't write. This was back when I used to call exams quizzes because I felt like it made them sound easier. Oh, but the students, they never really fell for it. Like, this is just as hard as the exams. But anyway, so I want to figure out how much time it takes to go from this point to this point. I know the y displacement, and so I can figure out the time in that way. I can say that y equals v naught y times t plus 1/2 ayt squared. V naught y, in this case, since it starts out horizontally, the y component of the velocity, gosh, what is the y component of the velocity? Well, if it's horizontal, that means there's no y component at all. So I'll just get rid of that term, that whole thing goes away, and I get negative 500 meters, because that's a ½ kilometer, equals negative 5 times t squared. So t then is the square root of 500 over 5, or the square root of 100, which is equal to 10 seconds. And then once I find the time, then I want to find out the distance. So if I know that the speed, this is the speed in the x direction, and I want to know the distance, d, or I'll call it x in this case, and I would say x equals vx times t, which is going to be 42 meters per second, times 10 seconds, or 420 meters. So D is the right answer. I think there's even a problem similar to that. It might not be asking for the distance, but there is a problem where it comes off horizontally and I ask you to solve for something. Solve for the time, or solve for the distance, or maybe I give you the distance and you solve for the initial velocity. in the x direction. I'm pretty sure there was one like this, but you shouldn't be surprised by that. We've done it before quite a few times.
So that's always projectile motion. Always look around for the time.
Always look, yeah, you'll want to know the time. So if I ask you, well, let's look at another one. This is a horizontal motion initially. Let's see if we can find one that is not horizontal initially. It doesn't look like there's one on this test. Huh? Right, yeah. So let's look at another one. That was fall 13. Let's look at fall 12. I think I have all these on my top. It's gone. All right. So like number 4 here, you kick a soccer ball. This, by the way, is fall 2012, number 4. Kick a soccer ball with initial velocity, 20 meters per second, angle of 30 degrees. It lands some distance away. How long does it take to come back to the ground? Expect to see questions like this. You'll see questions that are very similar to this. In this case, I have an object that comes up and then comes back down, and I just want to know how long does it take to come back to the ground. And I give you the initial velocity, v0, and I give you the angle, theta. And there are a couple ways you can do this. I can look at the velocity and how it changes with time in the y direction using the fact up here that it goes to 0, or I can look at the position. We did this in class, but I'm going to stick with the first one, the first way of doing that, where I say I know that the velocity in the y direction up top is equal to 0, and so I can say, well, vy equals v0y plus ay times t, so that's 0 equals v0y, which is 20 sine of 30. Make sure you know your x and y components cold, but you know how to do them quickly. Minus 10 times t. And so that's going to be 0 equals 10 minus 10t. So t equals 1 second. But then be careful because, often as is the case, that you might get a number en route, and I sometimes like to put those numbers as an option, just so that, so that you're certain that you know what the answer is. So the answer is not 1 second here, right? Because I'm looking for the total time, and this would just be half the time. So the answer would be 2 seconds, d. Because it takes 1 second to get up here. It's really, these projectile motion problems are really about finding the time. And then to find the time, you have to figure out what is it that I know, and then figure out what's the appropriate equation to determine what it is that I need to find out. Don't forget your equations. We only have 3 equations. I have one of them here. The velocity in the y direction. The y position is v0y times t plus 1/2 ayt squared. And then very similar to that is the x position, which is just vx times t. Notice here I've left off this term because ax is equal to 0. There are several questions too just about the nature of projectile motion, what happens in projectile motion. So make sure that you're familiar with what happens, that in projectile motion I have acceleration in the x direction is 0, acceleration in the y direction is -10. So my velocity in the y direction starts out big, gets small, goes to 0, and then gets bigger in the negative direction. And in the x direction, it's constant always, because that acceleration in the x direction is 0. As I said, make sure that you remember your velocity versus time graphs in the vy versus t. Did I start this recording? Yes. In the vy versus t, I start out big and positive, I go to 0, and then I get big and negative. That's what happens with the velocity in the y direction. And then the velocity in the x direction, see, I'll do it over here. Velocity in the x direction versus time it doesn't change, so it's just like this. Okay? Make sure that you understand what the velocity is doing in this projectile motion. What else? Let's see, we'll just sort of skim through here. Can I clear this? You're not going to see vector problems. So in the old test, you'll see vector problems sort of interspersed with projectile motion problems, but just disregard those. However, you do need to know how to do vectors, of course, for the force problems and even the projectile motion. Here's another example. That's practically identical. Well, it's not identical because you have different things given. Like in the first one, we were given the height of the table, and in this one, we're not. We're given the time. But you work it the same way. If you know the time, then yeah, this is still 2012. Number 7, you would work it practically the same way. You just say y is equal to v naught y times t plus 1/2 ay t squared. V naught y is 0, just like in that first problem with the plane. And ay is -10. You know t right here, so then you can solve for y. So y would be equal to -5 times t, which was 0.3 seconds squared. So that's 4.5. Wait, hold on. Yeah, -0.45. So A would be the right answer. On these tests, I use 9.8 for G. That's why it comes out a little bit different. But on all the past couple of years, I always use 10. Yeah.
Where did you get the -5?
Oh, so I just took half of -10. Because my AY is always -10. I think half of -10. No, we don't write the half. I don't know. Sorry. Okay. Yeah. Tyler?
Yes.
Yeah.
So v naught y times t, how would you cancel out?
No. It's only in this problem because it's a horizontal. The velocity is initially horizontal, and v naught y, in fact, is often not 0. But if it's a horizontal problem initially, where the velocity is in the horizontal direction, this does go to 0. These are tough problems, honestly. Students, they find these and the 2D problems with forces to be some of the hardest topics that we cover. So I don't mean to scare you in that, but I do want to, let you know that if you're having trouble with it, that's sort of okay. It's not, you want to not have trouble tomorrow, but okay. Remember about the hang time, the highest that goes in the air is the longest time for the projectile. And then we get into 2D problems. You want to do some more projectile motion, or you want to do some Newton's laws? Brian?
Number 2 on fall 2015.
2 on fall 2015? Exam 2? Okay, you're not going to have to use the quadratic at all. I'm surprised that they had to use it. Number 2? No, you shouldn't have to use the quadratic for that. This is the one? Yeah. Okay, so this is sort of our stereotypical projectile motion problem. Make sure that you know how to solve it backwards and forwards. I have an object that takes off, travels a certain distance. The V naught is 100 meters per second. The angle is 60 degrees. And I want to know what is the maximum height. So I'm going to start looking around for the time, and I don't see it in the problem. So what I want to do is find the time at this point. But I know some other information that Vy at the top there is equal to 0. So I can say Vy equals V naught y plus Ay times t, and I'll call this t top just to remind me. Vy is 0, This is 100 sine of 60. That's my y component of my velocity. Minus 10 times t top. So this is 87 minus 10 t top. So t top equals 8.7 seconds. And then if I have the time and I want to know the height, I can do it in this way. I can say the height now, y, is v naught y, t, plus 1/2 ay, t squared. Now that I know the time, I can find the position. And I know everything in this. I know v naught y. It's 100 sine 60, which is 87, times 8.7, minus 5, that's that half of negative 10, times 8.7 squared. I don't know what that gives me, but let's see. As I said, you won't have to use the quadratic at all. 760 minus 380, 400 meters. Okay. Again, what I did here is we look at the problem. I want to know what is the position here. So in order to find the position here, I have to know the time to get here. In order to find the time, I ask myself, what else do I know about this location? And I know that the velocity in the y direction goes to 0. And so since that velocity goes to 0, I can look at this equation. In fact, I recommend that you write the equations on your form at the beginning, so you sort of have them there right in front of you. There aren't that many. There's 4 or 5 equations that we've been using all semester. Find your time, and then you can find the y position at that time. Okay? Ryan? Okay. All right. Let's look at this one again. Sort of skim down through here. I want to look at some force problems. We can come back to projectile motion, but let's look at some force problems as well. Let's look at this one right here. I think if you're in the in-class section, we worked through this. I think it was in the clicker question. Woman weighs 700 newtons, so she steps onto a scale that's in an elevator. Then the elevator begins to accelerate, and now she weighs 500 newtons. Well, first of all, ask yourself, is she going up or down? She appears to weigh less than she actually is. She's appearing to be somewhat weightless, and so that means that she's moving downward. Right, so I can get rid of C and D. She's dropping. She's not dropping in free fall, but, almost, or enough to drop 200 newtons. So I can get rid of C and D completely, and now it's 50-50. So, but we want to get it just right. Let's imagine this is the lady. This is my normal force. This is her weight. This normal force, this is like what the scale reads. When a scale reads, it reads normal force, not weight. It's hard to measure your weight, but it's easy to measure the normal force. And so I say the sum of the forces equals ma. The sum of the forces is Fn minus Fw, and that's equal to ma. So I have 500 minus 700 divided by the mass. If her weight is 700 newtons, her mass is 70 kilograms. That's 700 divided by g, which is 10, gives me 70 kilograms. So that's divided by 70, which is our acceleration, which is negative 200 divided by 70. That's about 3. So B is the right answer. Let's look at some 2D problems. Can I clear this? So what?
How did you know that 700 was the weight and 500 was the force?
Okay, so this is her actual weight. A woman weighs 700 newtons. But when she gets on the elevator and it starts moving up or down, she has what we call an apparent weight. She appears to weigh less than zero. So she's standing on the scale, and as she's going down, that scale reads something less. The scale reads the normal force. And so that's what it says according to the scale, that the scale actually reads 500 newtons. So that should key you off that this is our normal force. And then you can find the acceleration. Make sure that you're also up to speed on, we've had something like this in the concept test, like this, where if you change the mass or you change the force, how does that affect bodies of different mass or acceleration or whatever? In those, you start with Newton's second law, F equals ma. So if my mass goes up, then my acceleration has to go down. So if I have something that's twice as massive, then I'm going to have half the acceleration of another object. We've had questions like that on the first exam, and we'll continue to have them the rest of the year. But questions that ask you, if I change one variable, what happens to the other variables? Going to have a few two-dimensional problems. Let's look at this one. This is a good example. You have one that's very similar to this. Not exactly like this, but similar. I have a 5 kilogram mass on an incline. It's moving up at a constant speed. Whenever it says constant speed, you should think, zero acceleration. If the speed's not changing, that means it has zero acceleration. And I want to know what is the tension in the rope. So on these inclined plane problems, which you'll have a couple at least that are calculations, and then a couple others that are just, concept tests, kind of like what we had. Like I will give you one of those where you have the equations, and you have to pick out the right or wrong equations. What happens when you change various things on the incline, like the angle, and to say the normal force or the tension in the rope or things like that. But here, if I want to know the tension in the rope, the first thing I want to do is draw all the forces that are being applied. I have force weight. I have the tension in the rope. I'll call this Ft. And then I have normal force. Do I have any friction? It says it's a smooth incline, and it doesn't say anything about friction, so we'll assume no friction at all. Draw our coordinate system. That's my y. Here's my x. Remember, this is plus x. This is plus y. And then I can redraw that over here and resolve my vectors. I have Fn, Ft, and then I have the components of Fw. This is Fw sine of 40 and Fw cosine of 40. So where did I get the 40 degrees? This is 50 degrees, so this angle right here is 40 degrees. You can sort of see that this is a triangle right here. If this is 50, this angle has to be 40. 90 minus 50. Always use this angle. It'll make your life a little bit easier when you're dealing with these. And then our x and y components are as we've been dealing with. So now we can look at this, and since I know that the acceleration is equal to 0, you could write out Newton's second law, and sometimes you might need to do that because it's more complicated. But in this case, you should be able to look at this and say, well, I know the acceleration in all directions is 0, so my net force in all directions has to be 0. So this has to equal this, and this has to equal this. I'm looking for this, so I just need to calculate this. I know the mass is 5 kilograms, so this would be 50 times cosine 40, and that would be the answer. If you do these enough, you begin to see how these things fall out, and you'll just be able to just skip right ahead to this step. That's okay. You don't have to be able to skip the steps. You should have time otherwise. But when you get enough practicing, you'll be able to skip around and see these things sort of as they come out. So 50 cosine 40, 38. Yeah, so A is the right answer there. That's a good question. You'll have a question. Actually, there is one very similar. It's not the same numbers, but it's an inclined plane. Pretty sure there's no friction. It's very similar to this. Alrighty? What if it's accelerating? If it's accelerating, you work out the same way. Say it was accelerating up the inclined plane, then you would just say the sum of the forces in the x direction is equal to max. And that would be Fw cosine 40 minus Ft is equal to max. I know, this doesn't ask for this to solve, but if you know Ft, then you can find what is the acceleration. Or if you know the acceleration, you can find Ft. Okay?
Say it's 2, and we do 2.
Yeah, so if the acceleration was 2 meters per second squared, let's say that it's accelerating up the inclined plane. Be careful with this. So let's say that it is accelerating at 2 meters per second squared, like William suggested. Be careful, okay? Because notice that this is my negative x direction, and so my acceleration is equal to 2 meters per second squared in the negative x direction. Be careful with that. If you see an arrow that shows the direction for the acceleration, or I say that the acceleration is up or down the inclined plane, that you check your coordinate system and make sure that you get the right sign. That's an excellent question. All right, so if my acceleration is -2 and I want to find my tension, I take this and I solve that for the tension. The tension then is Fw cosine 40 minus m times -2, which was, this was 38 plus 5 times 2. It's 48 newtons. Notice how the tension goes up. If I'm pulling it up at an accelerating rate, it should go up. The tension should be bigger here than if it's not accelerating at all. It should be bigger. Okay?
Earlier it has, well, yeah, right there it has minus Ft. Will it always be subtracting them?
No. No, you have to, let me show you another example where it would not. The same problem, but with a positive Ft. Right, if I had it like this, and this is Ft, now that Ft is in the positive x direction. It depends. Don't try to memorize that Ft is positive or negative, but draw your coordinate system and remember that this is positive x and this is negative x. That's the hard part to deal with, and it takes practice. Yeah. Drawing your coordinate system and realizing the sign of the axes. Madeline? Okay. All right, we good on this for now? We'll come back to some 2D. We have some other 2D that are similar but different.
Is terminal velocity one?
No, there's no terminal velocity. Terminal velocity just occurs when your net force is 0. I think I explained it in that question, did I not?
Yeah, it's 2 questions.
There were 2 questions about it? Oh, yes.
So it's when the air resistance is 0.
No, it's when the air resistance is equal to your weight. So you have a net force of 0. It's when you jump out of a plane, you fall, you accelerate for a certain time, and then at some point you go so fast that the air resistance equals to your weight. So you stop accelerating and you fall at a constant speed. But you don't stop. It's not on this at all. Okay? Yeah. Yeah, that's why I was getting a question.
I was just wondering something about you guys. Will we have an equation sheet for test?
No equation. Okay. For the next test, when we get into chapter 5. We've only had probably 5 equations the entire semester. That's why I don't have an equation sheet just yet, because wouldn't really be much on it. Just be like 3 or 4 equations. I know that y'all would like to have one, but we'll have one soon. I'm sorry, which ones?
20 and 21 on fall 2014.
How y'all feeling about this exam? That's been the general consensus. What's that? You know, a lot of it you're going to say, gosh, I know exactly how to do this. You say, I've done this 5 times, I know what's going on. And then some of it, you'll have done before, but it'll be like, I forget, because there's a lot of little things that come in that can trip you up. And, you know, with that, it's practice. I understand. I know it's difficult. It's sort of a new thing for a lot of us. Oh, shoot. Okay, 20 and 21. Okay, yeah, so I wanted to do one of these anyway. So number 20, this would be a 2D problem, but not on an inclined plane. But you really approach it pretty much the same way. Honestly, I think they're a little bit easier than the inclined plane because you're not dealing with all the rotated coordinate system and stuff. But you still approach it the same way. You draw your coordinate system. You draw your forces. Actually, I'm just going to skip ahead and draw a free body diagram. So I have this force, which is 20 newtons, at 30 degrees. And then I have 2 other forces. I have the normal force, and I have the weight. And that's it. The normal force and the weight. Then I resolve my vectors of Fn. Fw are 20 sine of 30. 20 cosine of 30. And Fw, but I know Fw is equal to 100 newtons because it's 10 kilograms times 10 meters per second squared. Now I want to figure out what Fn is. In order to do that, I'm going to have to look at the sum of the forces in the y direction. Sum of the forces in the y is equal to 20 sine 30 plus Fn minus 100 equals to 0. So that is Fn equals 100 minus 10 are 90 newtons. So B is the right answer. Tyler, I think you asked this, is that right? Russ. Yeah, good question. I could ask some other things. I could ask, what is the acceleration? Gosh, how would you find the acceleration? When I find the acceleration, you'd say, this is the only force in the x direction. So this force is equal to the mass times the acceleration. And that will give you the acceleration. You could also throw in some friction. You could say the kinetic friction is, I don't know, let's say mu k is 0.1. In that case, if I want to know the frictional force would be here, opposite the direction of motion. It would be equal to mu k times the normal force. So Fk would equal to 9 newtons. So I have a force over here of 9 newtons. In that case, if I want to know the acceleration, I'd say this force minus 9 newtons is equal to the mass times the acceleration. There are lots of different variations that we could do on these. Again, with practice, you'll know the steps to take. And the steps to take are always the same. You're drawing all your forces, resolving the vectors into their x and y components, and then applying Newton's second law. That's always the steps that you take. But sometimes there are other things that come in, like friction and the signs. You just have to be very careful with those. And Rustin, you said 21 as well? Oh, yeah, so that's, yeah. So, is that okay? Sure. Can I get my... So, again, label your coordinate system. Draw your force vectors. I already have one drawn on there, but I have another vector, which is my normal force, my weight. Then resolve my vectors. I'll resolve this vector is going to be 20 cosine of 30 and 20 sine of 30. Okay? And then ask myself, what is it that I'm looking for? And I'm looking for the normal force, so I need to look at the forces in the y direction because that's where the normal force is going to come up. And I say the sum of the forces in the y, this is applying Newton's second law, sum of the forces in the y is equal to 20 sine 30, because it's upwards, it's positive, plus Fn minus Fw equals 0, and then I solve that for Fn. I know Fw is 100, I know this is 10, this is 10, so I can solve for Fn. Any particular questions that are standing out to you? Want to look at? Exams, particular exams?
Which one is it? Say it's just a 1D problem, we don't know the entry angle and friction being the same as
No, it would be the same if we didn't have this force right here. The friction would change because your normal force would change. Remember, your friction is dependent not only on the coefficient but also on the normal force. And if the normal force changes, then it's going to change the friction. You'll see a couple of friction problems that are calculations, and then some that are also, just conceptual.
Explain number 18.
Oh yeah, you will see one like that. Number 18. Oh, on this test or on 2015? Yeah.
But there's one on here, I'm sure.
I'm sure there is. Let's see. Is there seriously not one on here? There should have been. Okay. Okay, like this one. So you'll definitely have one like this. I'll give you a block on an inclined plane. It'll either be stationary or it'll be accelerating up or down the inclined plane. And I'll give you some equations, and I'll either ask you to choose the correct or the incorrect equations. This one's asking for the correct. You can look at them if you know your inclined plane really well and pick out those that are incorrect. But it's probably better for you to just label all the, write out the correct equations, and then you can compare all of them to the correct equations. So in this case, notice there's no friction. Doesn't say anything about friction. Oh wait, no, it does have friction. It has static friction. So I'm going to draw my forces. I have the weight, Fw. I have my static friction, F sub S, and I have my normal force, and that's it. Now, if I draw my coordinate system over here, I'll go and resolve these vectors. Fs, Fn, those are already on axes. And then Fw. This is Fw cosine of 30. Oh no, it's 60, because you do the 90 minus bit. And then this is Fw sine of 60. You can probably stop there, but we see how these things are related. Like I know I can say Fn minus this is equal to 0. This minus this is equal to 0. So Fw cosine 60 minus Fs equals to 0. That one's okay. Because see, this minus this is equal to 0. Fw minus Fn? No. Because Fn is equal to Fw sine 60. So not good. Fw cosine 60 equals max? No, right? Because it doesn't have anything about this force. And Fw sine 60 equals Fn? Yes. So 1 and 4 are correct. A. 1 and 4 are correct. You'll have one of those for sure. You have to do that process anyway to solve those problems.
And it'll probably change if it's not stationary, right?
Well, yeah, sort of. I mean, if it's not stationary, the way it would change is that this would become max, and that's all that would change. Like if it was accelerating out the inclined plane, you couldn't say that this was equal to 0. But this would still be the same because it's never going to move in the y direction. It wouldn't be an inclined plane, it would be something else.
So how would 2 and 3 be correct? Like you said,
How could I correct these? Well, that one I would have to this one, there's not very much to do to correct this. I mean, the correct one for 2 would be Fn minus Fw sine 60 equals MAY, or that's equal to 0. Okay? And then the next one, yeah, guys, if y'all need to get up and leave, I'm not offended if you, whatever is fine. Fw cosine 60 is MAX. To make that one right, I'd have to put in an FS. You'll definitely have one of those. You're going to see a lot of problems that are familiar. All the problems you can do, but many of them will be familiar to you. It is possible to get a perfect score. I know that y'all think that seems impossible, but I've had students last test make perfect scores. It is possible to do it. I know that seems hard, but it's certainly possible. Okay, what else, y'all?
So work isn't done.
No work at all. No, work is chapter 5, so we're not going to have any work at all, just up through chapter 4. So usually in the test, they're broken pretty clearly into chapters, so when you begin seeing stuff about work, just stop there. All right. Like in an inclined plane? Sure. Pretty sure you have one on the test tomorrow. That your inclined plane has friction. I'm not certain, but I'm fairly certain. Sorry guys, let's see, that's 2013, 2012, 15, 14. Okay, so like this one, it asks, what is the coefficient of static friction between the block and the inclined plane to keep the block in place? We worked through a problem like this in class. It was one of our first examples. So process is still the same. I draw my vectors of my normal force. I have the static frictional force holding it in place, and I have the weight. And that's it. That's the only forces that I have. It's a static situation, so my acceleration in both directions will be 0. I resolve those vectors. Fn, Fs, and then I resolve my force weight. This is Fw sine of 60, Fw cosine of 60. And now this asked a couple questions. First, what is the normal force? And then what is the coefficient of static friction? Turns out you need the normal force to find the coefficient of static friction. So my normal force, sum of the forces in the y is 0. That would mean that the net force is 0. So these two have to be equal but opposite. So my normal force is equal to Fw sine of 60. That's going to be 100 newtons times sine of 60, which is equal to 87 newtons. That's my normal force. 85 if you use 9.8 for your G. Now, what is the coefficient? Well, I know that Fs equals mu s times my normal force. That's actually the maximum static friction, but that's okay. We can just keep it here because we're looking at we need the maximum static friction to hold it in place. So my mu is equal to Fs over Fn. So that would be how I'd find my coefficient, but I don't know Fs right off. I can find it though. If I look up here, equal and opposite these should be, because it's a static situation. So Fs should equal to this. This is 100 newtons for the weight. Cosine of 60 is a half, so that's 50. So Fs is equal to Fw cosine 60 divided by my normal force, which I've already found is 87 newtons. That's going to be 50 over 87. That's 0.6. Call it. Yeah, so A was the right answer on that one.
And that's one of those equations that we have to memorize.
Yes. You want me to write all those down?
Yeah.
All the equations that you need to know? There really aren't that many, and the ones that there are really things that we've been using all semester. So I have, for projectile motion, I have y equals v naught y t plus 1/2 ay t squared. This is one of our two kinematics equations, and then the other is vy equals v naught y plus ay t. That's our other kinematics equation. And then I can also write the one for the x equals vx times t. That's the same equation as for the y, but letting the acceleration be 0, and then also recognizing that vx is the same as v naught x. Because the acceleration is 0, the velocity doesn't change. That's it for that chapter, except, well, we need to know our x and y components. That v naught y is v naught sine theta. V naught x is v naught cosine theta. But that's just our x and y components. And then F equals ma. The sum of the forces equals the mass times the acceleration. And Fk equals mu k times the normal force, or closely akin to that is Fs equals mu s times the normal force. All right, so less than or equal to, as we talked about, that Fs actually increases until it sets into motion. And then that's it. There's nothing, no other equations, right? I can't think of any. Drew?
In the ocean class,
Hmm?
quiz,
Yeah, other
okay. There's just something for, this is for some quiz. And lesson 4.
Okay. Oh, nice. Okay. Can I go away from here? So this problem, this was one that everybody got. It's the skier on the inclined plane. Thank you. See you, Ryan. Had a skier on an inclined plane, and it said that the mass of the skier, I'm going to draw him as a block, but the mass of the skier is 62 kilograms. This angle is 25 degrees, and I want to know what mu k is if the normal force is known to be 45 newtons. All right, so in order to work this, I want to know, since I know that Fk equals mu k times the normal force, to find mu k, it's going to be Fk over the normal force. Okay, so if I know, they went ahead and told me that Fn is 45, but I could have figured it out, because the normal force is the y component of the weight. But I don't need to, because it's given it to me. Now I just need to find what Fk is. Let's label all of our vectors. I have Fn. This is Fw cosine of 65 degrees. I skipped a little step there, did you see? I didn't draw the force weight as it goes straight down, but I went in and broke it into its x, and now its y components. FW sine of 65. And then this is going to be FS. So the problem says that he is 62 kilograms. We'll assume that he's not accelerating. It doesn't say. We'll assume he's not accelerating, so that Fs then is equal to Fw cosine of 65. That's 620 newtons. I get 260 newtons. All right, so now we can plug that back in up here. This isn't right. Huh? Oh no, Drew. What's wrong?
We're solving for that, that's what. Yeah, FK.
No, I'm sorry, that should have been a K. Oh, okay, I'm sorry. I read the problem wrong. Y'all ever done that before? Read the problem wrong? It's not the normal force that's 45, it's actually the kinetic friction is 45. Okay, I'm sorry. So, that's funny. So this isn't right here. But what we do need to find is to find the normal force now. And to find the normal force, we say it's equal to Fw sine 65. The normal force is equal to Fw sine 65. That's 620 sine 65. Just 560, we'll call it. And now mu k is going to be 45 over 560. I get 0.08, which is the right answer. All right. Sure. Let's see if I want that up. I think there are inclined planes with friction on them. Was there another question on here?
Yeah, the question 4.
Not gonna see this. You won't see any quadratic equation. So
Okay.
you have to use the quadratic formula to solve this.
Okay.
Okay. Is that okay for now?
Yeah, that's fine.
I see where you got the ones in the left and then the given, but where did you get the FJ equals to K times FN equation from?
Oh, this is on that page of the things that you just need to know.
Okay.
Yeah, so you just need to know this. It was on this.
Oh, okay.
Right here. Okay. That's kind of new for y'all.
We have to solve for FS like we solved for FK.
Perhaps, yeah.
How would that work with,
You would. It would be like you'd be solving for the maximum. So you just visualize an equal sign on it, right? static is not moving. Especially in that case, when you're not moving. So if I have, you know, an inclined plane here, I have my static friction force, which is up. It's going to be equal to Fw cosine, let's say this is 30, cosine of 60. Those two will be equal. They have to be equal because it's static. It's not moving. This frictional force has to be big enough to hold this in place. They have to be equal but opposite.
Friction, static and kinetic friction always opposite direction.
Always opposite the direction of motion. Okay. Static and kinetic friction are clear. Let me just say what's correct and see if it answers your question. The static friction will always oppose the direction of motion, or in the case of static, it's not moving, the direction that it would tend to move. So this thing would tend to move down the inclined plane, so the static friction is what holds it up. Does that answer your question?
And kinetic friction would be opposite motion.
Kinetic friction, if the thing was moving down, if it was either accelerating or moving with a constant velocity, then this would be kinetic friction, not static friction. But it would still be opposite the direction of motion. Tyler, does that answer your question?
I'm just trying to figure out why static friction is less than.
Oh, because this is that thing, talk about this, how, like if I'm moving something, the static friction increases until it reaches the maximum. Because you can push, and as you put, and it's not moving, the static friction will increase until it reaches its maximum, and that's when it starts to move. I don't want to spill my coffee, but yeah. I don't think that really comes up. I mean, you need to know, I think that the static is greater than the kinetic friction. Okay, is that good?
Would it be a question like something to do with static friction and it's going to have acceleration to it? Because I don't remember seeing anything like that.
Well, no, I mean, if it's moving, static friction. But if it's, I don't remember.
Is that really make it whenever it just-
Because I'm mean? I'm not that mean. Am I? Just a little. I don't remember. Let's look at it though. It would be kinetic friction, not static
That's
friction,
right.
right? Yeah. Do they have class in here? Hold on, let me see. No class in here? Oh. You would treat it like the forces that we've been doing. Like let's do a 1D problem where let's say that I have some kinetic friction in this direction and then a force in this direction. And I ask you, let's say that the force is equal to 20 newtons. The mass is equal to 2 kilograms. Mu k is equal to 0.1. What is the acceleration of this block?
Okay, so you're going to give us information if you were not
Well, there might be an intermediate step. Is that what you're asking? Yeah, sometimes there are. Often there are intermediate steps. I mean, this is a one-step problem, pretty much. That you would say.
Force 20 equals 2A.
Actually, no, this isn't a one-step problem. This is a two-step problem because the first thing you have to do is find the normal force. The normal force is equal to the weight, which is 20 newtons, right? 2 times 10. And then you find Fk, which is 0.1. That's the coefficient, times the normal force, which is 20, which is 2 newtons. And then you solve Newton's second law. Sum of the forces equals ma. So it's not an easy problem. It's 20 newtons minus 2 newtons equals 2 kilograms times A. So A equals 18 over 2, or 9 meters per second squared. Sure, that'd be a fine test question. Well, no, I mean, you can do this, though, right? I mean, I know that y'all can do this. The incline planes that really trip up people. So I'll practice those. But I mean, practice the 1D problems, too.
Number 21.
Uh-huh. What, that's at 15, right?
Yes, sir.
Quick question real fast though, is it, I know it's the summation of the forces, but we're subtracting because the FK is opposite direction, correct?
Right, yeah. So if I draw my coordinate system, this is plus x, this is minus x. Yeah. All right. Which one? Okay, so which of these, on an inclined plane, the normal force is related in what way to the weight? If it's on a horizontal plane, the normal force equals the weight. But as it goes on an inclined plane, it's going to be less or more, you think? Less is right. It'll be less. In fact, if we think about our inclined plane, the normal force is in this direction, the weight is in this direction, and as we've been drawing our coordinate systems, my normal force is equal to the y component of the weight. That's Fw sine of, if this is 30, it'll be sine of 60. And a sine or a cosine is always 1 or less. So a sine is always less than 1, unless it's 90 or 270. And so the normal force will be less than the weight, because it has this extra little component in it.
So it'd be me.
Right, the normal force is less than the weight. Sure. Yeah. Like with an inclined plane or not? Let's see, I'm just going to make up one. Is that okay? So I have some rope holding it. Let's say that the mass is 5 kilograms. Let's say that it's accelerating in this direction at, what would it have to be? I don't know, 1 meter per second. Sorry. I want to know what is the tension in the rope. And let's say that this is 60 degrees. Now, if there was no rope, it would be accelerating at a bigger rate. It would, let's say no friction, it just has this tension holding it. But I follow the same steps. I draw my coordinate system. Then I draw my forces. I have Ft, Fn, Fw. And that's it. Then I resolve my vectors. Fn, Ft, Fw, sine of 60. Sine is always our y component. Shoot, you're right. Thank you. And then, since I'm looking for the tension, I look only at the x. I say the sum of the forces in the x is equal to Ft minus Fw cosine 30 equal to ma x. But notice it's accelerating in the x direction. In fact, it's accelerating in the positive or negative x direction. It is in the negative. So the way I do this, I'd say Ft equals Fw is 50. Hey, Marco. 50 newtons cosine 30. Plus 5 kilograms times negative 1 Feeling? So that works out to be 43 minus 5, 38. That's your tension. But it's a lot like previous problems, right? It's a lot like the friction problems. It's a little simpler than the friction because you don't have to deal with the normal force. I don't have to figure that out. But it's not simple. Right?
It's like that. 15 goes down to 30, and I'm getting math.
Oh man, I do not know how to get rid of that. I've never found that in my calculator. I don't know. Google it. If I use one of these calculators, how do I get rid of radicals? It doesn't give decimal numbers. Oh, sorry, if you figure it out, I mean, okay. I think you can do like numbers and I have no idea. Oh, you could have moved. You could have engineered. No, I'm not sure. Sorry. Google it. You can sure there's an answer that somewhere. All right. Is that all for today? For now? I think there's another class coming in. COE. Any other questions? So did I do that wrong? 50 cosine 30. Did I get
I see what it is.
okay. All right, is that all for 5 pounds?